Hello everyone, and welcome back to Kerbal Space Program, where I continue to work on a plugin that will allow the KSP Interstellar-like setup with the reactors, generators, and thermal nozzles separated to work with system heat, which generally expects things to be bundled together. So a reactor and generator are one part, so that the same part is both creating the thermal flux and also generating the electricity, or generating the thermal flux and also generating the thrust. So we are trying to separate those out the way KSP Interstellar has it, because then I can make the KSP Interstellar parts compatible with system heat. So right now I've made the KSP Interstellar radiators compatible with system heat. But to make the reactors, generators, and thermal nozzle compatible with system heat, we have to have this plugin to translate this system into something system heat understands. So that's very complicated because of what system heat is expecting. And previously I had shown the reactor and the generator working together, and this time I have a thermal nozzle. So that's one of the features of KSP Interstellar that's really nifty, is you take any of the reactors and you slap a nozzle on it, and you basically get a direct fission or fusion drive, NTR or any of the others. So that's convenient, as long as you size it properly. And if we activate the reactor here, we see here we have a system flux of 900 kilowatts. It produces a total 1.5 megawatts. Of that, 600 kilowatts is currently absorbed by the generator being turned into electric power. And then we have the thermal nozzle. And as long as we have this on, the thermal nozzle will give us this thrust and this delta V. However, not that thrust. That's a lie. So here's the thing. The thermal nozzle is complicated. You can see there's no thrust listed here. And that's because the thrust is dependent on the amount of spare thermal energy from the reactor. That's the complicated bit. It's a spare thermal energy because some of it is being taken by the generators. The generators get priority here. So first, the generators take what thermal energy they need to generate the electricity, and then the waste gets dumped through the thermal nozzle. There's still going to be some surplus heat that needs to be dissipated by the radiators. And of course, if the thermal nozzle isn't actually producing thrust, then the radiators have to get rid of the entire 900 kilowatts. So there's a very complicated setup that we have to do. It says thermal output 2 megawatts, but that's because it's rounding from 1.5. So we do have a reactor throttle, and right now it's not showing the actual time here, unfortunately. There's one of those compromises that make, and if you might have noticed that with other setups as well, especially in KSP Interstellar, that the time here doesn't correspond to reality. And that's more of a KSP flaw than anything else, as far as I can tell. I can't figure out how to work around that. Basically, this time right... Okay, so there are two options. One, I put the basic engine module on here, and that is the module engine FX, the one that runs the normal stock engines, and have this ISH thermal nozzle separate. And if I have it separate, then this will read the right time. The problem is the stock module will override it, which is ironic, right? You would think, okay, wait, this is going to be calculating the right thrust, right? The thrust that we're supposed to be getting from the reactor. And if it's alone, this is reading the wrong amount of burn time. It's reading the time that's written into the configuration instead of the one that's calculated on the fly. But if you put the stock module in, this will read the right burn time with the thermal nozzle. And it's just a weird thing with the way things get updated. It will read the right burn time with the nozzle, but when you go outside, the nozzle will get the stock amount of thrust. So, so we have to deal with the fact that the burn time is wrong there. That's all I can say. It's been a pain. I'm sure there's some workaround or something, but the fact that KSP Interstellar sort of has the same problem in that the VAB often shows the wrong burn time, leads me to believe it's not so simple. Okay, so out here, we can change the attached propellant, by the way. There's no methane here, it's just hydrogen. I've only got hydrogen and methane as choices here for now, but it's a configuration file that has the list of propellants. There's also a configuration file for the list of different types of reactors. So we can have a liquid core or a gas core or something like that. And what that'll do is it will produce a different specific impulse. So the specific impulse is dependent on the propellant and the type of reactor. So we'll detect the type of reactor, and based on that, multiply by a multiplier that's associated with the propellant, and then give you your specific impulse. And that's how the specific impulse is determined. And once the specific impulse is determined, then we can determine the thrust, because we get a certain amount of thermal flux from the reactor, and that is what we use for the thrust. And basically it's the thermal flux, I'm going to simplify it, thermal flux divided by the ISP is going to give us a thrust, okay? So let's get into orbit to actually make it work. No errors yet there. I did put a reaction wheel on here, and honestly, the reaction wheels are more powerful than I thought they were. I always thought that they were weak in Realism Overhaul, but this is pretty good actually, turning this. Now you see that the stage time is 2 days, 6 hours, and 56 minutes there. So horrible, but that's what you'd expect. There's only a 500 kilowatt, the electrical output is 600 kilowatts. There's a 1.5 megawatt reactor, and the NERVAs were like 1.5 gigawatt. So 1,000 times what this can output. So of course we're not going to get a lot of thrust out of this. We're going to get 1,000 times less. In this case, 168 newtons. So not great. We hear the sound, but I've only got a stock plume on here, and I've just made it clear for now. So we hear the sound of it working, and you can see it ticking down properly. When I had the earlier problems without when I had the stock module on here as well, and I was trying to have ISH thermal nozzle overwrite the thrust of the stock module, this was being consumed at the stock module rate instead of the 168 newtons that I was supposed to be getting. It is having an effect. You can see our apoapsis is going up from the 168 newtons, and we will very, very, very slowly be accelerating. Of course, if you have a bigger reactor, the idea is that you can have more thrust. But there is another way to get more thrust here. Shut down the generator, right? Right now, we've got 1.5 megawatts. Of that, 600 kilowatts is going to the generator. Basically, the generator is taking the 1.5 megawatts, but it only has the efficiency of 33%, I guess it's 30% or something like that. Anyway, it's got its efficiency, and then it's going to send the rest of the waste heat through the nozzle, is basically how this is working. And so right now we've got the rest of it going through here, except for the inevitable amount of heat that the reactor will generate anyway. So you can't get rid of all the heat. The reactor still is producing 75 kilowatts of heat. So that still has to be dissipated by the radiators, but if we take a look at it right now, they're doing fine. The loop temperature should be going down, I feel like. System flux is like that. I'm surprised that the loop temperature is so high right now. Hold on a sec. Oh, it says generated 65 kilowatts and removed is 765 kilowatts. Heart temperature is going down. Well, I guess it's alright. So, we are generating the thrust here. And if we throttle down, it's a weird part of the math that it's not the top bit. It sort of ignores some of it, and I'm gonna have to figure out why the math is working out like that. But if you throttle down, eventually we get more waste heat, you see. But I was about to say we can get more thrust out of this by shutting down the generator. So toggle generator. Now you see that we have a 1-day burn time and 290 newtons, and that's because all of the thermal output of the reactor is going through the nozzle. And it's still a 1-day burn time. So, of course, we're going to need to be able to use Pekka's warp thrust mod with this, and it doesn't work right now, owing to the fact that I haven't put warp thrust on it. So I'll have to put warp thrust on this nozzle. You can see the warp thrust module is not here. So yeah, I'll have to fix that part. This is progress, but there are things that still need to be done, so I'm not releasing it yet. And it'll be part of the future tech pack. And the things that need to be done is I still need to adapt it to tweak scale. Eventually I want to create a radiation system for this, such that you need a shadow shield. But how I want to implement that so that's usable is a complicated business. And yeah, so I'll give that some thought. But we'll be able to have different types of propellant and different kinds of reactors that's already been set up. I just need to make sure that this can be tweak scaled properly. Right now, the system heat reactors, or the reactors from near future or far future, don't seem to tweak scale properly in terms of their heat output. So if they don't, if the ones that are already made for system heat don't seem to tweak scale properly for the heat output, I'm not entirely sure I can do it, but I'll try. It should be possible, but it can get complicated. And tweak scaling, you know, it has to communicate properly with all the parts when we tweak scale. This is a fresh nozzle that I decided to make. I hope it meets with approval. It's not like the other one, though of course it gets inspired by the RS-25 like nozzle that we have in KSP Interstellar. Otherwise it's fairly simple. I've changed the reactor a little bit so that it has the coolant pipes going along it down to the nozzle. So even if you don't have the nozzle, it'll have those pipes, but then they could be pretending to be supports or something. So that is the idea. This is a bimodal NTR now. That's what this is. A bimodal NTR is one that can generate electricity like that and generate thrust through the nozzle. The trick is, though, that the thrust that you get is really low because you have to otherwise dissipate all the heat. So if I turn this off, now the radiative flux is going up, and then we've got increased efficiency. You can see the amount removed is going up, and now it has to deal with the full 900 kilowatts from the reactor that isn't being taken up by the generator. So the generator is using some of that energy to do the electricity thing, but we still have the vast majority of the reactor output. So in that case, you need to be able to throttle down the reactor. If you wanted to get down to the 75 kilowatts that we were getting when we were using this, then you would have to throttle down the reactor down to somewhere around here-ish, about 8%. Then you could have the same radiators while this is running and while it's off. So while it's running, the reactor will be at 100%, and then while it's off, the reactor will be down to 8%. But then the power output's only 48 kilowatts in that case, while you're lugging around a 1.5 megawatt reactor. So that's trade-off. So what it means is that you could have a much larger reactor in order to get more thrust from the thermal nozzle, but then you have to back it off when you're just in electricity generating mode. But that's possible. You can do that. And then your power output would be limited here. I haven't added a separate generator throttle here because we already have the reactor throttle and I didn't want to complicate things. But KSP Interstellar actually has a separate generator throttle, and I'll consider that. I don't know if it's really necessary. But that's how it works. Then you can limit the amount of heat you're generating and you don't have to have as large an array of radiators. Now, these aren't very large. That's because they are high temperature heat radiators. And a reminder that the radiators, their effectiveness, the amount of heat they dissipate, goes up by the fourth power of the temperature they can handle. So the fact that these are high temperature and have a very high operating temperature there means that they are very efficient. If you've seen other radiator arrays, they might not. They might have a lot more area to deal with the same amount of heat, but that's all depending on what kind of operating temperature they have. Like titanium radiators generally operate at about 500 Kelvin, so not very hot actually. Anyway, so that's the idea, and hopefully it meets with people's approval, and I'll continue to work on it. The main thing before I release it is tweak scaling it, and also adding more reactor parts, so that's not just this one. There'll be other looks to the reactors, but ultimately this setup is also meant to enable adapting the KSP Interstellar parts to system heat. So when I do that, I'll be offering configurations that will get rid of the original KSP Interstellar module and add the system heat this system heat module, so you can use it with system heat. That way we don't have two different heat systems, but we can use all the parts so that we have different looking ships. We can have different looking reactors depending on the preferences of our design, because Nertea's parts have a very particular kind of aesthetic, but sometimes you want a different aesthetic. So anyway, that's the idea, and that's the Interstellar System Heat plugin. I unfortunately didn't come up with a better name for it, so continuing to work on that. With that, thank you for watching. I hope you enjoyed this video. If you did, please do press like. If you have any comments or suggestions, please leave them in the comment section below, and I'll see you next time.